Hey everyone, today we will be talking about circles and limaçons. So next in our lesson on polar equations, we're going to learn about these circles, cardioids, and limaçons. These are all types of curves that can be represented by polar coordinates and polar equations. Remember that polar coordinates represent points in a plane by their distance from the origin, the pole, and the angle they make with the reference direction, the polar axis. These curves often exhibit symmetry. For instance, circles are symmetric with respect to rotation about their center. Cardioids and limaçons can have various forms of symmetry depending on their equations. So let's dive into them individually. Circles. We've seen this before. A circle is a closed curve in a plane that is the set of all points equidistant from a fixed point called the center. A circle is symmetric with respect to any line passing through its center. The equation of a circle in the Cartesian coordinate system depends on the center and the radius. In the top equation, HK is the center and R is the radius. This equation is likely to be an equation that you're already familiar with. The second equation is the polar equation of a circle. Limaçons. Limaçons are fascinating mathematical curves that resemble snail shells. Limaçon is derived from the French word for snail. Here is the polar equation for a limaçon. If B is greater than or equal to 2A, the limaçon is convex. If 2A is greater than B, which is greater than A, the limaçon is dimpled. If B equals A, the limaçon is known as a cardioid. If B is less than A, like in this graph, the limaçon has an inner loop. But don't worry, we're going to look at some examples. This is the graph of R equals 1.5 plus cosine theta. As you can see, B is greater than A, but less than 2A, so the limaçon is dimpled. And as we can see in this example, B equals A. Therefore, this is an example of a cardioid. You may notice a cusp at the origin, which makes this a heart-shaped curve. We can see cardioids in the real world, in physics, engineering, and even art. They are used in designing reflectors and radar and sonar systems, as well as being used as patterns in art. I encourage you to mess around with the equation of limaçons. There are many, many cool shapes that you can make.